Started.
Okay, so before we move on to our next topic, let's take a peek at doing one of these estimates. I'm going to do number 2 since it's the more difficult of the two. So we're going to start off with the general constant here, the number of studs is 12 over 16. We're assuming 16-inch centers. Times our perimeter here, which is, what is that, 56 by 36, 184 feet. So 12 sixteenths times 184. I'm just double checking there. 56, 36. It is 184. So 12 divided by 16 times 184 is 138. So we start out with 138 is the first estimate of the number of studs we need. Next, we need to add 2 for every corner. We'll have 1, 2, 3, 4, 5, 6 corners. So that's plus 12 for the corners. We have plus 1 for every odd length wall, non-modular wall. 36 is modular, that's divisible by 4. 24 is modular, that's divisible by 4. This wall here would be 10, that is not divisible by 4. That's one of them. 32 is divisible by 4. 26 is not divisible by 4. This wall over here would be 56, that is divisible by 4. So there's only 2 for non-modular walls. Next, we add 1 for every interior wall partition. We have 1, 2, 3, 4 spots where the interior walls intersect the exterior walls. So plus 4 for the interior partition intersection. And finally, we add 2 for every door or window. Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9 windows and 2 doors. That is 11 totals times 2 for each. 22 for doors and windows. So that is a total of 16, 18, 40 that we're going to add for those. 138 plus 40 is 178 studs. So that was for the second one, the weird shaped one. Number 1 over there, I'm assuming went a little bit easier than that. There are no non-modular walls, so we don't have to add for that. What was it, 84, so 168 is our perimeter. I'll just get the total for you quick so you can double check. $126 plus, we're going to do 8. 1, 2, 3, 4, 5, 6 more for walls. Oops, somebody had a comment? Question? There are no non-modulars, and we had 1, 2, 3, 4, 5, 6, 7, 8, 9 windows, 2 doors, 11, so plus 22. That's going to be plus 36. There should be 162 studs for the first one. Again, I didn't go through that one in detail for you, but you should come up with 162. If this were a quiz or a test, if I had that type of question, If you were within 2 studs of that, I would give it to you. Any questions? Okay, so that's what a lot of those algebraic formulas look like when you apply them to an application. They aren't just a straight up formula. They are a formula like the number of studs equals 12 over 16 times the perimeter, but then there's that adjustment factor, and that adjustment factor is plus or minus however many, according to different characteristics within that object that you're working on. So it's not quite a straightforward formula like most of our algebraic formulas are. So today we're going to look at working with our algebraic numbers. To work with our algebraic numbers, we need to be able to treat our numbers, algebraic numbers, just like any other number. When we add or subtract, remember, we need the same name. We're going to combine counts. And we're going to keep the same name. So for our algebraic numbers, having the same name is the variable and its power. 3x plus 5x can be added because those both have a name of x. We combine counts. 3 plus 5 is 8, and we keep the same name of x. 2x plus 7y cannot be added because they have different names. X and y are different names. So that's just going to remain 2x plus 7y. Similarly, 6 plus 4x cannot be added. This has a name of ones. Whenever there's no variable after a number, that's ones is its name. So we have ones and x's. We can't combine those with addition or subtraction because those have different names. Well, 5x to the third plus 3x squared falls in that same category. Even though they both have a name that's an x, this is x to the third and this is x squared. We have seen with our units that an inch to the third or inch cubed and an inch squared are very different. The same is true for our x's. If they have different powers, they are different names. So we cannot combine those with addition and subtraction. But we might be able to combine part of it without being able to combine the whole thing. We might have things like 7x plus 5y plus 3x minus 2y. So when we look at this, we have the pieces that have the same name. 7x and 3x have the name of x. Now both of those are positive. There's no sign here, but that's implied to be a positive 7. There's a plus in front of the 3x, that's a positive 3x. Positive 7 and positive 3 make 10, and we keep the same name of x. For our y's, we have 5y, and that's a negative 2y. The sign in front of it goes with the digit that comes after it. So a positive 5 and a negative 2 makes a positive 3y. Now we have to have a symbol linking those two digits together. Since it's a positive 3, we put a plus in there. So it's 10x plus 3y. Similarly, we might have 8x squared minus 5x plus 3x squared minus 2x. We can combine the things that have the same name. 8x squared and 3x squared have the same name. Positive 8, positive 3 make 11 x squared. We have negative 5x and negative 2x. Well, negative 5 and negative 2 make a negative 7. This is where you got to remember your negatives, your integers. and we keep the same name of x. Well, our algebraic numbers can have multiple digits and multiple names. We might have something like 3x squared plus 5x minus 7. That is a single algebraic number with different digits. Very similar to our whole numbers where we had place values of 10 squared and 10s and 10 to the 0. Well, this is place values of x squared and x's, and x to the 0 is a 1 just like 10 to the 0 is a 1. So if I put that in parentheses, that parentheses is not an enclosing symbol. It's not telling us to do something there first because there's nothing to do there. It's just saying that is a single algebraic number. We might add that to 5x squared minus 9x plus 4. To add those, we line up the place values. So I'm going to start with my 3x squared plus 5x minus 7. Then my second number I'm going to write below it, I'm going to line up the 5x squared with the 3x squared. My negative 9x is going to line up with my positive 5x. I'm going to line up my positive 4 ones with my negative 7 ones. And I am adding here. Negative 7 plus 4. So negative 7 plus 4, that is a negative 3. 5x plus negative 9x. Well, this is a positive 5 plus negative 9. That's a negative 4. And we keep the name of x. 3x squared plus 5x squared. Well, 3 plus 5 is 8x squared. So we get x squared minus 4x minus 3. Where it gets to be tricky is when we have things like this. When we go to write this out, first number here, the 3x to the third minus 7x plus 2, we have to recognize that there is a power of x missing. These are written, and it's proper grammar to write them in what's called descending order. The largest power of the variable to the smallest power of the variable. But when we do that with this first number, one of those powers is missing. There is no x squared. So we have to put in that 0x squared. So 3x to the third plus 0x squared minus 7x plus 2. We had to have that 0x squared in there because now when we put in the next number, there's 4x squared. That has to line up with the x squared. So that lines up with that 0x squared. Positive 3x lines up with the negative 7x, and the negative 9 ones lines up with the positive 2 ones. And again, we are adding here. So 2 plus negative 9. 2 plus negative 9. Here's 0, that's a positive 2. Negative 9 is a negative 7. Negative 7x plus positive 3x. Negative 7 plus positive 3 is a negative 4. And we keep the name of x. 0x squared plus 4x squared is 4x squared. Now that's positive. Since I have more digits to put in front of it, I have to put that plus there to link them together. And there's nothing to combine with the 3x to the third, so I just leave that there. Give us that answer of 3x to the third plus 4x squared minus 4x minus 7. A lot of people get to this point and they want to try to combine things, but they cannot. Each of those digits is a different name because it's a different power of x. There is nothing more that can be combined there. We are done at that point. Well, where these algebraic numbers can be rather tricky is with subtraction. Let's take something like 5x squared minus 8x plus 4 minus 8x squared plus 9x minus 7. So again, I'm going to rewrite this lining up our columns. So I have my 5x squared, negative 8x, positive 4. I put my 8x squared under my 5x squared. Positive 9x under my negative 8x. And my negative 7 ones under my positive 4 ones. And now I am subtracting down each of these place values. So this is a 4 minus a negative 7, which will become 4 plus 7, which is just a positive 11. This is negative 8x minus 9x. Negative 8 minus 9 is a negative 8 plus a negative 9. Negative 8 plus negative 9 is just a negative 17. And we keep the name of x. 5x squared minus 8x squared. Well, 5 minus 8 is a negative 3. And we keep the x squared. I warned you back at the beginning of the semester when we did those integers that the negatives would come back to haunt you. Well, here's one of the spots where we have to be very, very careful working with our negatives. I'm going to have you try one of these subtraction problems in your notes quick. (2x squared plus 9x minus 6 minus 7x squared minus 8x plus 5. Give you a minute, and then we'll go over that. So we line these up. We write out the 2x squared plus 9x minus 6. 7x squared goes underneath the 2x squared. Negative 8x goes underneath the positive 9x. And our positive 5 goes underneath our negative 6 ones. And we are subtracting. Excuse me. So now we're going to subtract down these columns. So we start with the negative 6 minus 5. Negative 6 minus 5 is negative 6 plus a negative 5, which is negative 11. So it's negative 11. Or 9x minus a negative 8x. Well, 9 minus a negative 8 is 9 plus 8. It's a positive 17x. 2x squared minus 7x squared. Well, 2 minus 7 is a negative 5. And we keep the x squared. Any questions on that one? Okay. Well, we've talked a little bit about dealing with exponents. If I have x to the third times x to the seventh, that as long as we have exponents with the same bases, remember, this is the base, that's the x, and the 3 would be the power of the exponent. We have exponents with the same bases. Both of these have a base of x. When we multiply, we can add the power. This becomes x to the power of 3 plus 7. That's just x to the 10th. If we were dividing, x to the 8th divided by x to the 5th. If we're dividing exponents with same bases, both of those have bases of x again, we can just subtract the powers. That's x to the power of 8 minus 5, which would be just x to the third. Or if we have a power of a power, x to the 5th to the power of 4. We don't have to worry about bases because we only have one base. We're just multiplying powers. That's x to the power of 5 times 4, or x to the 20th. So now as we start to combine our algebraic numbers with multiplication and division, we remember we do not need the same name. We're going to combine the counts as always. We're going to also combine the names. So I might have 3x times 8x. We're going to combine the counts. 3 times 8 is 24. But also combine the names. X times x is x squared, just like inches times inches becomes inches squared. But we didn't have to have the same names there. I could have had 5x times 4y. I would simply combine the counts. 5 times 4 is 20. And then also combine the names. X times y is xy. We can have exponents on those variables, like 3x to the 5th times 7x to the 8th. Those are different names. The x to the 5th and x to the 8th are different names. We would not be able to add or subtract them. But since we are multiplying, we can go ahead and combine counts. 3 times 7 is 21, and then also combine the names. X to the 5th times x to the 8th is x to the 5 plus 8 is 13. We can have multiple names. We can have 5x to the third y squared times 6x squared y to the 5th. We're going to combine the counts. 5 times 6 is 30. Combine each name. X to the third times x squared is x to the 3 plus 2 is 5. And y squared times y to the 5th is y to the 2 plus 5 is 7. We might have 3x squared y times 11 x to the third y to the 5th. Well, again, we combine counts. 3 times 11 is 33. X squared times x to the third. Well, 2 plus 3 is 5, so that's x to the 5th. Now the y here, we got to think of that as y to the power of 1. Y to the 1 times y to the 5th. 1 plus 5 is 6. That's y to the 6th. In your notes, I want you to do 6x to the third y to the 5th times 7xy squared. We'll go over that in about 30 seconds. So we multiply the counts. 6 times 7 is 42. We also multiply the names. X to the third times x. We'll think of it as x to the 1. 3 plus 1 is 4, so that's x to the fourth. Now, it might look like we're adding there, but we are multiplying. But the net result is the powers get added together. Y to the fifth times y squared. 5 plus 2 is 7, so that's y to the seventh. Well, we might have more than one digit in one of our numbers. We might have 3x times 5x minus 7. To add something like that, it's just like having any other two-digit number times a one-digit number. We write the two-digit number on top, the one-digit number on bottom, and we multiply. This would be 3x times negative 7, which is a negative 21x. Whenever there is no variable there, remember that is ones. So ones times x is just x for our names. Then we have the 3x times 5x. 3 times 5 is 15, and x times x is x squared. This is actually the full way, the long way of multiplying out that problem. Now, most of us have been learned a shortcut rather than doing it the full way, and that shortcut is called distributing. To distribute, we just take our original problem here. We start with the 3x. Then we do 3x times 5x is 15x squared. And 3x times, to make sure that's in negative 7. 3 times negative 7 is negative 21. X times 1 is just x. Notice we get the same result. It just saves us from having to rewrite the problem, and it keeps it in a lot smaller space. To me, this makes more sense, actually. But there are going to be a lot of applications and a lot of problems we do where it's going to be nice to keep it right within the problem. So we are going to go ahead and use this distributing just to save space and to make it more convenient when we get into more complex problems. Now let's jump right up to something with multiple variables in it. 5x to the third y squared times 7x squared y minus 4xy to the fifth. And let's go ahead and just do that distributing here. So we get the 5x to the third y squared times 7x squared y. 5 times 7 is 35. X to the third times x squared is x to the fifth. Y squared times y, again, think of it as y to the 1. So 2 plus 1 is 3. That's y to the third. Now we move to our next digit. So the 5x to the third y squared times, remember that's a negative 4x y to the fifth. 5 times negative 4 is a negative 20. X to the third times x, think of it as x to the 1. So 3 plus 1 is 4. That's x to the fourth. Y squared times y to the fifth is y to the seventh. We might have something like 3x squared y, or x to the fifth y squared times 5x to the third y squared minus 7x squared y to the fifth plus 2x y to the third. This is still the same process. We just got an extra digit to work with. 3x to the fifth y squared times 5x to the third y squared. 3 times 5 is 15. X to the fifth times x to the third is x to the eighth. Y squared times y squared is y to the fourth. Next, we're going to multiply the negative 7x squared y to the fifth. So 3 times negative 7 is a negative 21. X to the fifth y squared is x to the seventh. Or sorry, x to the fifth times x squared is x to the seventh. Y squared times y to the fifth is also y to the seventh. 3x to the 5th y squared times the 2xy to the 3rd. Well, 3 times 2 is a positive 6. So I put the plus in there. X to the 5th times x. Again, think of the x to the 1. That's x to the 6th. Y squared times y to the 3rd is y to the 5th. And that's it. So I'm going to have you guys try one in your notes. We're going to do 5x squared y times 4x squared y squared minus 7xy to the 4th plus 3y to the 5th. I'll give you a minute, and then we'll go over that one. Let's take a peek here. 5x squared y times 4x squared y squared. 5 times 4 is 20. X squared times x squared is x to the 4th. Y times y squared is y to the 3rd. 5x squared y squared times a negative 7xy to the 4th. 5 times negative 7 is a negative 35. X squared times x is x to the 3rd. And y times y to the 4th is y to the 5th. 5x squared y squared times 3y to the 5th. 5 times 3 is 15. It's a positive 15, so I'm going to put a plus in front of it. X squared times, there isn't anything other x's, so that's just going to stay x squared. Y times y to the 5th will be y to the 6th. So there it is. What if both numbers have 2 digits? Like 2x plus 5 and 3x minus 4. How's that going to work? Well, just like any other numbers, we can set that up and do the long multiplication. So we would start on the right and work our way back. Negative 4 times the 5 is negative 20. Negative 4 times 2x is a negative 8x. We move over to this next digit. We're going to have to move over a spot down here most likely. 3x times 5 is 15x. And sure enough, we have to move over to stay with the x's. That was a positive 15x, so I'll put a plus there. 3x times 2x is 6x squared. We've got negative 20, nothing to combine with that. Negative 8x and positive 15x is a positive 7x. and the 6x squared. Now there is a shortcut that many of you learned. If you took algebra, you've seen it, called FOIL. FOIL is just an acronym. The F stands for first. Combine the first digit of each number. 2x times the 3x is 6x squared. The O stands for outside or outer. We combine the outside digits. That's 2x times negative 4, the negative 8x. The I stands for inner or inside. That's 5 times 3x. That's a positive 15x. And the L stands for last. So we multiply the last digit of each number. 5 times negative 4 is a negative 20. Notice we get the exact same numbers, just in a different order. We combine them. The negative 20, negative 8, and positive 15 is a positive 7x and 6x squared. We get the exact same result. It just organizes a little bit different. You can actually do a very similar multiplication with whole numbers. I just chose not to show you alternative ways to multiply because I didn't want to confuse you. Division is very similar. We might have 8x to the 5th, y to the 3rd, divided by 2, x to the 3rd, y squared. We combine the counts. 8 divided by 2 is 4. X to the 5th divided by x to the 3rd, well, 5 minus 3 is 2, that's x squared. And y to the 3rd divided by y squared, well, 3 minus 2 is 1, so that's y to the 1, or just y. So that's 4x squared y. Now, a lot of people don't realize that if we have a number like 486, and I'm dividing by 2, if each digit divides out evenly, we can just do that. 4 divided by 2 is 2. 8 divided by 2 is 4. 6 divided by 2 is 3. It's that simple to divide that out. We don't have to go through the long division process. With our algebraic numbers, we're going to do something very similar to that. We might have 18x squared y minus 12xy to the 3rd plus 24 xy to the 5th divided by 6xy. So we're going to divide each digit. 18x squared y divided by 6xy. Well, 18 divided by 6 is 3. X squared divided by x is just x. And y divided by y divides out. It cancels out. We'll move over to the next digit. Negative 12xy to the 3rd divided by 6xy. Negative 12 divided by 6 is a negative 2. X divided by x divides out. Y to the 3rd divided by y, well, it's 3 minus 1, so it's y squared. And finally, 24xy to the 5th divided by the 6xy. 24 divided by 6 is 4, so it's a positive 4. We'll put a plus in front of it. X divided by x cancels out. Y to the 5th divided by y. 5 minus 1 is 4. That's y to the 4th. So 3x minus 2y squared plus 4y to the 4th. So what we have for homework is all out of the big book. Page 389 through 390. Exercise 13-2. Page 392 through 393. Exercise 13-3. Page 396. Exercise 13-4. And page 399 to 401. Exercise 13-5. And of course, just working on the odds so that you can look up your answers in the back of the book. Any questions?
Is quiz 11-12 due tomorrow?
Let me double check. I was kind of in a rush this morning, so I didn't get a good look into the... I believe there is a quiz sitting out there, though, for us. Yes, quiz 11-12 is due by noon tomorrow. Thank you for bringing that up. Let's do it noon on October 27th. So that's on some of the basic algebra. Any other questions? So we've got
What
about
did
5
the
minutes. Oops, go
oh,
ahead.
what did the O and I in FOIL stand for?
Outer and inner, or outside and inside, whichever way works best for you.
Okay, thank you.
You bet. Any other questions? All right, so we've got about 5 minutes left. If you'd like to get started on the homework, I'll be on the network here to help you out. Otherwise, I realize you are at home today, so if you would like, you are free to go.